about our project. This is our ME-106 project. Essentially, we just made an automated ball thrower. The components that we have used in this project is a power supply that was provided to us from our ME-106 lab. It's a DC power supply. Then we have a torque motor, a motor that has a transmission which has gearing, which gives it the more torque. We have a relay. We'll get more into the component, the circuit side of it later, but it's a relay because we wanted to run more power, not from the Pico, but from the power supply. And then we have the Pico board for all of the talking and the software and everything. And we have the light sensor. It works as a button, turns it on. And then we have an ultrasonic sensor, which is in turn supposed to turn it off if a distance is less than or the threshold. Basically, we start off from over here. The motor is connected, and we have a code. We hit the code. Basically, we tap on it. So we're blocking the light going into the light sensor, which detects, and then it initiates the rotation over here, and then it starts rotating. What basically does, I don't have it powered on, but basically it's supposed to turn. The mechanism goes down, and then there's supposed to be a belt here. It broke while we were demonstrating, but as you might have already seen it, but it broke when we were demonstrating. There's a 1-to-1 ratio. There's a tensioner here. It goes around, and this is called a Geneva drive. Basically, when this rotates 1-to-1 ratio, Geneva drive rotates one per time, and it dispenses one ball into the basket, or yeah, I guess the pocket of the ball. And then once that's done, it shoots it. Obviously, it's running slow right now because we didn't power it right now. And it shoots it, and then it comes back again, 1-to-1 ratio. Geneva drive rotates, comes back, and dispenses a ball again. That's basically the gist of it. And we can also control the speed of the bar using there's an inbuilt potentiometer in the power supply, so we can turn it on, off, and we can dial it up. The more we dial it up, there's a threshold of this motor which is about 7 volts. We shouldn't go more than 7 volts because it'll fry the components. So the good voltage we worked out was about 4.5, which gives it enough speed and torque for it to drive smoothly. Talking about the component parts or the circuitry, basically, Saveli would talk to you more about this.
So the way this whole system works is, as soon as we turn it on, it starts reading the value from the light sensor. When it falls below a certain threshold, it sends a signal to the to the Pico microcontroller, which then turns this relay on. The reason we need the relay is because, like Harpreet mentioned, this runs off of 4 volts. The max voltage on the Pico is 3.3. So if we would run 4 volts through the Pico, it would fry the board. That's why we were using an external power supply over here, running it through the relay, and then directly to the motor itself. When the motor is on, it starts looking at the value on this ultrasonic light sensor. The reason we chose to use an ultrasonic light sensor is because ultrasonic distance sensor, is because originally the plan was to have it positioned on this rail here, looking at the balls, and then when there was no longer any ammunition left to throw, then it would turn the machine off. However, when building it in practice, it turned out that the sensitivity of the ultrasonic sensor isn't high enough for us to be able to read this small distance, and so instead of using it as a stop when there's no longer any balls left, we just decided that we're going to use it as an off switch, and when you hover your hand below a certain distance, it turns the machine off.
And now we'll give you a live demonstration of how it's supposed to work. To mention, we don't have a belt that runs. We were demonstrating it into the lab, and it broke.
So
And
this
this was the belt.
this is the belt that was here,
You don't have to put it all the way into it.
but the belt ran through the machine, went back around, and was in a loop. Unfortunately, broke. Now I will.
And that also drives the Geneva drive, and the Geneva drive cannot work because there is nothing rotating it.
Yes.
So we would have to manually put a ball into the thrower, and then it's going to launch. Or Saveli could turn the.
I'll turn the Geneva drive by hand to demonstrate how it works. So right now, I start running the code. As you can see, it's reading the light sensor value. As soon as I tap it, it's going to turn the motor on.
Basically,
Now the
that's what
motor
it's
is
doing.
running.
So basically, that's how it's supposed to work.
Obviously, my
Obviously,
timing is off.
and then to demonstrate how to turn it off, there you go.
There
And
it
to
is.
demonstrate how to turn it off, Saveli is gonna just hover over it for a little bit. So Saveli's gonna hover over it. All right, stops.
Yes.